I will lead you through the presentation here, and first of all, I will not talk about maritime shipping. Sorry for that. I understood you are all maritime enthusiasts, but this is our sprint before the coffee break, so relax and listen. And it's about sustainability, and thanks a lot to my keynote colleagues introducing all the very important topics. And you see, so we as a port, I'm from the HHLA in the port of Hamburg, and so we from the conservative industry, so why are we engaged in Hyperloop technology? So, but I will get you through it. So it's about hinterland transport and how we want to do a revolution in hinterland transport. So, the largest button, yes. So, it's about, so the Hyperloop transport technology is a company engaged in Hyperloop transport, which is a maglev, magnetic levitation transport solution for passenger. They started in 2013 to develop everything for passenger transport, and later on we thought, of course, why not doing it also for cargo transport? They have the headquarters in LA, and they are spread all over the world. And HHLA from Hamburg and Hyperloop TT, Hyperloop Transport Technology, joined forces to develop the cargo transport. So why are we doing it? So we hear a lot why we do need changes in transport and maritime transport, sustainability, but we also have some physical challenges in the port. So everything where your vessels arrive, where everything arrives, we have some challenges, short of labor when it comes to the hinterland transport, to supply the ports, to bring all the cargo you transport on your vessels and make the vessels work. There is a really shortage of labor, so we have really costs in the port due to waiting time, due to congestion, and so on. And and all this, we try to think about how to solve it and how to, okay, we need more driver, is that so easy? But shorten the time, lower the costs, and we are working on a solution how to bring the cargo faster out of the port and faster into the port autonomously, and therefore really facing the issues and the problems that we have in transportation currently. So I'm just skipping this because we are all aware of this. So we need efficient, safe, sustainable transport, frictionless, profitable, high speed. So this is what we need, this is what we are doing. These are the key words that we have on our agenda when thinking about the new solutions. And what is it? So we are trying, or our aim is really high-speed transport, really to travel at almost airplane speed on the ground. And it's also about not a competition towards shipping, maritime shipping, but it's of course enhancing the whole transport chain. And also the chance to think about end-to-end processes and think, we saw a nice slide there where we have the smart transportation, the smart shipping, the smart ports, and actually we need a smart supply chain. We need thoughts about what is the smartest way to bring the cargo from A to B, the whole chain. Everybody is focusing on its topic, that's right, but in the end, it's really, we have to think about how the whole chain is working very well. And this is the chance for us with a Hyperloop to think about the end-to-end solution. So you will see it later. What is it basically about? So I have shortly, in a couple of slides, we have a short movie, so there you see really how it works and what's the idea behind it. But in general, it is a capsule. It is about a vehicle driving in a tube which is close to vacuum. This is the important point. So it's not just a vehicle driving through a tunnel, but a vehicle driving through a tube close to vacuum, which is, of course, you need pumps, you need power for that, and so, but this is really what it makes it and what facilitates the speed that we are looking for. So you have the vehicle in the tube, magnetic levitation, and what we are really thinking about, having a zero-emission transport system, having really gaining and generating energy with panels all over the tunnels, and so ending up with a sustainable solution. And the nice thing is, it's not only we are not only writing concepts, and the introduction was right. I'm from the Hamburg Port Consulting, so we consultants try to concept everything. But what is here happening is that it's really there. So we have, if you see it on the left or upper picture, there's a 300-meter track tube in Toulouse. So there is where we are testing daily how to keep vacuum in such a system. We have the airlock, that is this abstract picture you see on the right upper picture. This is an airlock that we need to get the capsule out of the system, because as you see later, we try to get container cargo in this capsule, and it has to be, so you have to get the capsule out of the vacuum, put it into the put the container into the capsule and then get it in, and there you need some airlocks, and it's quite a lock, as you see. Yeah. And then you see on the lower left picture, this is a pump, an air container, and so there are pumping units already existing and already working in Toulouse, and and it's quite challenging to do it, so that we are very happy that we can test it for more than 1.5 years there. And then on the lower right side, you see the prototype of the capsule that we also have at the test facility in Toulouse. So it's not just about talking, we are constructing and developing the things to make it work. Okay, so we have the test center, as I said, in Toulouse, and we are working on a commercial prototype in Dubai, and we are working on a commercial route in the Great Lakes in the USA, where we conducted a very comprehensive feasibility study on how to do it, how to connect metropolitan areas, how to combine passenger and cargo transport on one track, and so on. The same questions that we have in rail, and if you see the rail development over the last 100 years, so this is really, how can it be faster, how can we combine it, is it, and we are also calculating, are there pure cargo lines feasible? Is it a feasible solution? So, and now we have the movie about, and before you started, just a second, it's about the hyperport. And so everything comes together, so we have quite a link to the Maritime network today. So coming from the port of Hamburg, working together with the guys from the Hyperloop TT, what we from Hamburg can really provide for such a project is port operations. What we can do at HHLA in Hamburg is container handling and cargo handling. We are doing this for more than 130 years, not containers, but cargo in general, and for the last 50 years in containers, of course. And this is what we really can provide to this project. And why is a company like HHLA from this port industry engaging in this? Because we believe that not only the shipping on the sea and not only the port, but as I said, the end-to-end logistics and the hinterland transport is very, very important for port locations, for transport, and so on. This is why we engaged here and call it, and that is also the project name is then the hyperport that we designed. Okay, can I start it, or, oh yeah.
Introducing a new era in cargo transportation. Efficient and autonomous Hyperloop integrated ports capable of airplane speeds at freight costs. Moving containers hundreds of kilometers in minutes instead of hours with zero emissions. Drastically reducing port congestion, pollution, and footprint. Reclaiming valuable waterfront property and moving ports inland. Resistant to all weather conditions. Transporting 2,800 containers a day on a single line system. A fully connected, sustainable system for balanced logistics. Revolutionizing cross-continental commerce. Welcome to a new era of sustainability, speed, and reliability. Welcome to the Hyperport.
I think this shows quite well what we are thinking about and what is the main idea about it. Yeah. So, and the major question when we started the project in 2018 was is it possible to bring a container into such a system? And surprisingly, technically, it's possible. You have to design a capsule, you have to design a tube, and everything is a little bit larger than originally thought for passenger transport. So this is the real challenge, even when it comes later to feasibility and viability of such a system. So what we did during the last 2.5 years is that we worked on a concept, technical concept, how to make the procedures around the port and how to combine the port facility, the hyperport facility, with a Hyperloop system. And working on business cases. So again, saying with our partner Hyperloop TT, one of the only Hyperloop companies also thinking about business cases and viable solutions. Also something that was for us at HHLA in Hamburg as somehow impacted by the Hanseatic merchants, so we are looking for viable solutions. And this is a partner not looking on the fancy technology stuff, but also looking on business cases, saying, okay, what is it? What is it about? What can we do? And then we designed the capsule, and we designed and made up our thoughts about the port, and now developed a virtual reality demonstrator for it, and would show it on an ITS Congress, which is next week in Hamburg. And after that, project goes on, so not seen here, but project goes on. It's then about really involving the market, and we are starting discussions with ports, with forwarding companies, with shipping companies, saying, okay, what is the demand? What are we doing? So what are we looking for? And before I dive again into the hyperport itself, I just want to stress these viable topics, saying, okay, what could it be? What could be a solution? And is it about a solution from Hamburg to Munich? Will we really build this tube from Hamburg to Munich in Germany next year? Definitely not. So we are looking for building up a test track somewhere. That is what we are doing now. And but the business cases behind it, and that is in general what we thought about, is there are 3 different business cases that could be interesting for such a solution. One is the off-dock depot, or the off-dock terminal, which is very much connected to port and to port operators, where a port operator having space issues in the port, they have the opportunity to build a terminal outside, not outside the port in the sense of 5 kilometers, but having the opportunity to build a site up to 300 kilometers somewhere in the inland, in the hinterland. So, and then you are really away from the metropolitan area where everything is expensive and actually everybody wants to live in the port, and there's no space anymore for cargo handling in the ports. So this could be a solution, because when you travel at a speed of 600 kilometers per hour, so 300 kilometers is nothing. You can really integrate it in your vessel operations. If you some transports on some terminals, currently horizontal transport take 20 minutes to half an hour. So this is nice. This is what we are talking about. So just giving you an idea, not diving into these cases, but having an idea. Then we also have the classic dry port, so connecting the port to a distribution center in the hinterland. What we have with rail today, what we have in the whole logistics, where we really transport things to a hub and where then it's distributed further. So this is of course something connecting clusters, connecting industry clusters, and even then over larger kilometers, over larger distances that we think today. And the last but not least, the third business case that we are thinking about is the land bridge. So the connection to port itself gets a little bit lesser, and where do we have huge land bridges currently? We have, as we all know, the Silk Road, the new Silk Road currently. We have East Coast, West Coast, USA. We have, so just to name 2 examples, but is that also a market for such a system? So building such a system over such kilometers from Shanghai or Wuhan to Europe is quite an investment, but is an opportunity, and is again an addition to transport opportunities, and is no competition to maritime transport when you have seen the 2,800 TEUs per day. So this is high quality, high speed rail, which really needs cargo that can pay for this. So, and there is a new opportunity. So it is no competition, and it will of course not replace maritime shipping. Okay, to give you an idea, we are calculating on that. We're saying, okay, what are the costs? What is the market willing to pay, and so on. And just to give you an idea, what we all consider is we are also thinking about operator models. Who will do it? Who will build the infrastructure? Who will operate a capsule? Who will operate a port? Will a forwarding company own the capsules, or is there a capsule owner? Will we, as Hyperloop TT and HHLA, operate it all and only sell the services? So this is what could be players in this: infrastructure operator, capsule operator, port operator, and so on. And as you see, there are different operators and different functions in it. And what is it about? And this is, I have no answer to this to you today, but we are also thinking about what could be the best combination, and of course or constellation. And of course it depends on the case or the condition, the country, the region where you are. Okay. This was some more on the commercial part to give you an idea. Coming back a little bit to the technology, saying, okay, what were really the challenges in this hyperport project to coming closer to maritime again, saying, okay, we really need a facility that can be integrated in existing ports. So we are not standing there saying, okay, there's a new system where everything has to be new. We ignore the existing world. So this is, as you know, not possible. And so how can we build something that could be integrated easily into an existing port, into existing container terminal? And so we were thinking about the port facility itself, and when discussing about this in the team, we came very fast to this conclusion, okay, we need another capsule. The capsule has to be designed, the vehicle has to be designed very differently to the passenger vehicle. So, and there we spent a lot of time on designing and constructing the capsule. Okay, and as you have seen in the movie, so the major thing is you see the capsule, which are obviously not in the vacuum now. So they all pass through a airlock. And there is and the capsules, the system is capable to handle departing capsules in a frequency of up to 40 seconds. So this is the frequency capsules can run through this system. So we are currently calculating with 60 to 65 seconds each. Then, so the airlock procedure, I don't want to annoy you with these technical facts, but just to give you an idea and just to convince you that we are really thinking about the details, is the procedure in an airlock is taking far more than 60 seconds. So sucking the air out of the tube or pushing it in, pumping it in again takes longer. So how do we handle it? How can we speed up these pumping, and should we put more capsules into a tube or into a airlock, and so on. If we put more vehicles in an airlock, then the airlock is larger and probably the pumping takes even longer, and so on and so on. And this is really what we thought through, and this is why it took us 2.5 years to be there where we are. Okay, then you see in the movie these fancy cranes, which are great, but you can also imagine, and this is what we changed in our virtual reality model, which can be experienced in Hamburg next week. We integrated existing cranes. It's quite easy to put this facility close to a rail operating facility or whatever, or put a rail container crane over it. So the integration is very easy. And then we have also thought about, as I already mentioned, the dry port or the off-dock depot, how to handle it in an inland port. So just go through rail, not rail station, but go through Hyperloop station. So, and this, just to give you an idea how we think about it, so you have 2 lanes where capsules can pass, and then you have the cranes over it. The interesting thing there is, coming back to the idea of end-to-end logistics and end-to-end solutions, is that we also took the chance to think about how to transport the containers on horizontal level, in the terminal or right to the door-to-door to the consumer. And there we also have some cooperations with other technical partners where we are working on this autonomous driving vehicles for the terminals, and also thinking about on the public roads. And you all know the discussion about this, but this is, and I want to stress this again, really a chance when looking on such a new transport system, that we can really use it to implement other technology, other thoughts. And the very first step, we also thought driving with an autonomous vehicle into the tube or into the capsule, which we, due to dimensions, quit. But this is something we are thinking about. And then I have some charts with me where are some informations on, because afterwards you get this everything in PDF, and then so there's something in writing and you can read it and not only pictures. So so each capsule can carry two TEUs or one 40-foot container or one 20-foot container, and everything probably interesting for all of us here. All the accelerating or the braking of these capsules, of these vehicles, is designed so that we can use the standard sea container where we have millions of, and we do not, this is what is the aim of this project, actually not using another container, another package, so which we have in aviation, for example. Of course, the thought lies very close, saying, okay, yeah, why putting this huge container in it? But the aim is really not changing the container, the package, but putting it in. And so this is also something, how much G does for how much G braking is a container designed and so on. You are all aware of this. Again, just to mention this and to convince you that we are really believing in this. Yeah, and of course, sustainability, I don't want to stress it. We really believe that this system can be operated CO2 emission-free, so because we generate all the required energy by ourselves. We have, very high speed opportunities by this vacuum. Yeah, so flexibility, yeah, not first place, so being kind of self-critical, so flexibility in truck is unbeatable in the hinterland transports. So we still have a track with the Hyperloop, we still have stations, we need the last mile, and so, but we have 1 to 2 packages that we can send with very high speed. And the capacity, as I said, is not replacing maritime transport globally, but providing an opportunity, transporting cargo in this system. And I really believe in this, that there would be a market, or that there is a market for this. Just looking at the example and not talking about the Silk Road, and don't want to judge about the Silk Road here, but what we all experienced during the last 10 years is that the system Silk Road, the rail from Europe to China and back, suddenly there is a market where there is high value, there are high value goods that we are transporting with a train to China, and we are transporting organic food from Europe to China, and nobody thought about this 10 years ago. And this is only an example, and this is an example that we experienced in our lifetime, and this one, among others, is really convincing me that there's a market for this kind of transportation. I have no clue about my time limit, but I think this is it, what I wanted to bring over. And if there are any questions, just shoot now or later. Thank you very much.
Frank, thank you so much. I'm sure there are many questions from the floor. I will invite, I think, 1 or 2 questions, and then we can take the other questions at the coffee break to save some time. But is there any question?
Some technical details.
We have a question over there.
Thank you so much. My name is Tina, and I'm working for Maersk Sealand. So, yes, my first question is, legislation-wise, is that something that you're looking into? And then I actually also have another one, timeline. What do you expect, right? Because you have set a project like this into the sea, and you must have some kind of expectation that at some point of time you will start to use this new type of transportation. Thank you.
Yeah, thank you, thank you. Legislation is a very important question. We think about it, and the question was in the beginning actually, do we orientate more to aviation because we are transporting so fast, or do we more orientate to rail or land transport? And we decided, and also got commitments from authorities which are responsible for land transport, especially rail transport, and so legislation will be more orientated to railway transport. So we are not making up a legislation currently, but the decisions or the discussions about it are going on. And just to add, what already happens in Europe, and as you are technical experts, I think probably some of you know, there are already standardization committees existing all over Europe thinking about standards, and this was also a topic this morning, standards in Hyperloop technology. How can we start such a new era of transport and technology, not making the mistake having all these plugs that you showed earlier all over the Europe, different tubes, different, I don't know. And I'm joining the German standardization committee, and yeah, we are really thinking and talking about with engineers what can we standardize, what has to be standardized, and in what way. Just in addition to the legislation. Time-wise, it's about, I always say, we can build the port today. The hyperport, which is loading stages, crane, and the airlock you see, we can build it today, actually. We are looking for as I also said, for test track, not 300 meters like in Toulouse, but some kilometers of test track. This is something, hopefully, we have a decision on during the next 6 months, where we really have a track, where we really can prove the system and the reliability. And on that, we have to build on this and then discussing where to establish a network. Not something that we will do tomorrow, but will take us 5 years probably.
Question for you that's actually come in through from the virtual audience. So Nick Lambert has asked, do you foresee requirements to modify ship and container designs? If you could please elaborate on your discussions with and reactions from shipping companies.
Great. Make it lighter. So actually, coming from the port industry, I'm working in the port for more than 20 years and really enjoying the standardization by the container, and we all know what it brought to the global trade and so on. That standardization is so great. The challenge here is, of course, the size of the container, but it's not us saying the industry has to change. And the aim of the project actually then is not changing the container to a system, but establishing a system that can be integrated in the real world. And can we design it? So we have the smart container already, so this is nice. We have all the data about the cargo inside the container. My first thought would be, make it lighter, not so heavy. Yeah.
Thank you.
Just as technical, one of the things I've done with our
Questions I need to ask them to be through the microphone, just because of our virtual audience as well. Yeah.
Yeah, so Don Miller, Globe Tracker here. We actually make the smart containers, right? So
right.
We install devices and sensors on the boxes. And one of the biggest challenges that many of the lines have today is container damage. So one of the highest return on investments for the technology is actually using the G-force sensors to monitor the shocks and these types of things. I guess with this now and the interaction of the container with the Hyperloop system, those pods are also subject to potential damage and or damage to the hulls, as you load them in and so on, because despite all the tech we have on the proximity sensors, it's still sometimes a little challenging to get that type of thing. So I guess maintenance infrastructure around those pods, and would they work in a Hyperloop if they weren't sealed completely? Just a couple of technical, just curious.
Mm. So if I got it right, so we designed the technology so that actually make it easy. Everything is the impact on the cargo inside the container. That is what you mean. Is as you drive on the rail or on the road or whatever. So this is not changing. We really said, okay, we do not want a system where the warehouse in, I don't know, knows this container will in the supply chain go at one time into a Hyperloop, and that's why we have to pack it like this. So this is not something we do. So everything is as today, but faster. So that is the one point, and the other point is so we need the capsule. So this is also something I did not mention, but so we need the capsule because in the capsule we have atmosphere. Of course, the capsule itself is closed, and we have atmosphere because a container with most of the cargo is not made for being in vacuum, even not for half an hour. So so this is why we need the capsule, and yeah, and so then when it comes to, I don't know, additional data that we generate, or
well, obviously the sealed capsule then creates the vacuum inside as well, because you need to seal it so it's airtight.
Yeah,
correct?
it's airtight.
Yeah, it's airtight. So if you were to sustain damage to the capsule, then the capsule couldn't go in the Hyperloop. Is that
right?
Right.
That's
okay.
right.
Yeah, just trying to kind of get my head wrapped around it.
Right.
Yeah.
And a good question, and this is really it's a complex topic, and so we also thought about maintenance, how to integrate maintenance into this, and how to check the capsule, is it right to go into the tube? So what happens, I know this question is burning somewhere, what happens if a capsule breaks down in the tube? Yes, then we have a problem, and we have to solve it. If a rail car breaks down today on the rail, we have a problem, we have to fix it. This is something we are working on. This is where we make risk assessment, risk procedures, emergency procedures, and so what happens if we do have a fire in the capsule? Is this possible in vacuum? I don't know. So all the things we are thinking about, I did not have slides on that with me today. But this is what we are thinking about. And the capsule has atmosphere to protect actually the container with the cargo. So
Thank you so much.
Okay.
Thanks for the question.
Kathy? Diana had one. Okay, I hear that there is one more question back in the room there. Diana.
From Bunker Trace, just moving so I can see you. I haven't seen you yet. Good to see your face. There's a poll.
Yeah.
I just have a question regarding on your last slide. You mentioned it can be connected to renewable energy. I have no concept of the energy requirements for Hyperloop TT or such distances. So if you could comment on energy requirements and consumption, and then secondly, whether or not there is renewable energy infrastructure even in your zones that you're looking at to connect to, or whether it's a self-contained system.
Good question. What I know is that if we put solar panels on our tubes all the way, we produce more energy than we actually need for driving the capsules and for operating the maglev technology. If you're asking me honestly about technical data regarding what power is needed, I have to look it up. Yeah, and this is also why we look on this infrastructure and say, okay, how can we use it? Yeah, and now we see often the tubes on pillars. But you can put it, of course, on the ground, and this really depends on where you build it. Yeah, and of course, we will have some tunnels where we then have no solar panels and so on. But the calculations from the energy engineers is we can operate it with these solar panel energy, and we produce even more than we need. That is And we need, of course, energy for the pumps. Yeah? This is the second. It's maglev and the vacuum. So every 5 kilometers, we have a vacuum pump cluster, so that this vacuum can be kept.